Hello everyone. I will try to beat AcropoliX today, and maybe I will also play Polish Alphabet if I beat AcropoliX. Let's go. Oops.
I have to delete my Patreon account. It's really annoying, but I'm having to start again from scratch building up a new Patreon profile. So if you like my work and want to support it, then now more than ever I would really appreciate you going to my new link, patreon.com/AlexOC, where you'll get early access to episodes as well as getting them ad-free. You'll also find at that link information about why I have to delete and restart my Patreon account. This obviously isn't ideal, especially because my channel simply wouldn't be where it is today without Patreon. If you're already supporting me on Patreon, there's information on the old page about why this is happening and what you can do if you want to continue supporting my content. But now I give you David Deutsch. David Deutsch, welcome to Within Reason.
Hi.
I'm excited to talk to you. I was reading your book just recently on an aeroplane actually, which is why for the viewers watching, you may notice it's a slightly different background to usual. I'm in a hotel room, or a motel room in Miami, and we're currently balanced on top of a microwave in a suitcase, so that accounts for the change in circumstance. I was reading your book on the plane over here, The Beginning of Infinity, and right at the very beginning, you talk about the nature of our universe. You talk about our planet being part of a solar system, and the solar system being part of a galaxy, the galaxy part of the universe, and then, rather confidently, you say that this universe is part of a multiverse, just one universe among many others. I hear people talk about this as a matter of conjecture all the time, but the confidence with which you painted a picture of this multiverse into the very beginning of your book made me want to start by asking, what gives you such confidence that this multiverse exists?
I don't know if confidence is the right word. I have as much confidence in quantum theory as I do in any of the other superb theories of physics, which are our best knowledge of the world. The fact that all these decades after, it's almost a century since the theory was proposed, and half that time it has been known that it describes a multiverse, and yet
it's disgusting.
That proposition is still
why is it so hard?
Disputed by most physicists. When I say most, people ask me how many. I don't know, but those who adopt the many universes form of quantum theory, or Everettian quantum theory, as it's called, after Hugh Everett, who proposed it in 1957, are perhaps 10% of theoretical physicists, but the proportion is much higher in certain branches of physics, where you have to actually ask what is happening to bring about the predictions that quantum theory makes, rather than just using the predictions as a sort of almanac. Philosophically, I think that, yes, so one of the excuses that's commonly made is to call this an interpretation of quantum theory rather than calling it quantum theory. That's a kind of a trick. It's a bit like creationists calling the theory of evolution an interpretation of fossils.
Right.
Because after all, no one's ever seen a dinosaur, no one's ever seen other universes. No one's ever seen fossils are actually stone.
Now let's rest.
Which is just evidence of...
I like the way David Deutsch looks. He looks cheerful. I like him.
Of dinosaurs, not actual dinosaurs. And similarly, interference phenomenon are just evidence of other universes. They are not themselves other universes. So the logical connection between these things is very tight. It's the same level of excuses being made.
So you mean to say that your you said confidence is the wrong word, and perhaps it
Yeah.
is, but your confidence in the truth of something like a multiverse is similar to your confidence in the truth of something like evolution by natural selection on the
Yes.
basis of the available evidence.
Yes.
I mean, that's quite extraordinary, and I want to jump into why that is, and why quantum physics does point to a multiverse. But just beforehand, you said you don't know how many scientists are on one side or the other of this debate. But for those who aren't in agreement with you here, for those who don't look at this evidence and see it obviously pointing to a multiverse, why do you think that happens? If, as far as you can see, this is a fairly straightforward deduction to make from the evidence, why are so many people missing it?
It's not a deduction. It's the usual thing. It's the only known explanation of the evidence, just like in the case of dinosaurs, that we know they existed. So why has this happened in physics? Well, I don't know. Is the short answer. It's some kind of sociological phenomenon of 20th century physics. You have to remember that at the time when quantum theory was proposed, there were very few physicists in the world, especially fundamental theoretical physicists. They all knew each other. It was a little culture, a little subculture or a little society of its own, and it was therefore unstable to small numbers of influential ones of them grabbing onto a false doctrine. Now that wouldn't matter, because ultimately all doctrines turn out to be false in science. But
maybe.
trying to enforce it dogmatically, trying to put down questions like what brings about the outcome, trying to put down those questions as being illegitimate questions. Like, if you ask that, you haven't understood quantum theory, or else nobody can understand quantum theory. You're not supposed to understand it. Or quantum theory isn't supposed to be a theory of the world. It's supposed to be a theory of how we see the world.
It's still hard.
And
Well,
that kind of thing. All of which are well-known excuses in all sorts of other areas. But in physics, they've somehow become entrenched, and some people say it's because the original generation then trained their students to fear to ask certain questions. It might be that, it might be something in the wider society. The same thing could have happened in relativity. Einstein, when he was young, was very strongly influenced by the positivism of various people, including especially Ernst Mach, who was a physicist but also a very emphatic positivist philosopher. And early relativity was in fact inspired by this positivistic insistence on let's just ask questions about what we can see rather than the absolute space underneath it. Well, Einstein, in a certain sense, took that to heart by saying there is no such thing as the absolute space. There's only relative times and distances, and therefore, for example, simultaneity doesn't exist. So, but when it came to general relativity, that didn't work. You couldn't say that the underlying space-time doesn't exist, because the underlying space-time is actually the substance of general relativity. And so Einstein had to drop positivism completely and go across exactly to the opposite extreme, which is why he rejected the growing consensus about quantum theory. This is often said to be a case of Einstein rejected quantum theory, but that's not at all true. He rejected the view of it, the excuses that were put forward by its pioneers for not taking it seriously as a theory of reality.
So talk to me about the kind of phenomena that we're observing in quantum mechanics that leads us to this.
Yes,
This amazing conclusion that we've been talking about so far.
Yes, it's one of the most amazing things that
fast.
physics has discovered. So I don't think the most amazing, but one of the most amazing. One way of looking at it is, traditionally the way that people have looked at it is to look at the theory and just say, well, let's apply what we've been taught as physicists, as students, how to connect the equations of the theory with predictions about reality. And you can labor through that process. The first people who proposed the many universes version of quantum theory did in fact go by that route. They were Schrödinger came up with the idea just before Everett, probably in the early 50s, but he never published it. So Everett was the one who first published it. And so their accounts are rather mathematical. They're saying, look at the theory, let's do what we normally do, and not make excuses for not believing what the theory plainly says. That sort of thing. Now,
The UFO was so free
not a
when I
physicist,
played this for the first time.
appealing to that training is not very convincing. So I'd rather go by a different route and say, well, how do we explain the experiment? So there are very many experiments now, and they are completely uncontroversial. The outcomes of these experiments are used in other experiments and in technology and so on. So there's no doubt about what will happen in the experiment. It's just that the prevailing view is to shut up and calculate. In other words, don't ask about how the outcome comes about. And the simplest case is the famous two-slit experiment or multiple slit experiment, where a single particle is aimed. Should say that a single particle is in quantum theory is not quite what it is in classical physics. It's spread out a bit, which normally doesn't matter because it's spread out by a very small amount, which we can only detect in these specialized experiments. But got to remember that it's spread out a little bit, and you have two slits which are
so
separated by less than the amount that the particle is spread out.
That
So
took
you
me
can do this experiment at home. I mean,
like
it's
5
not that
minutes
small.
or 6.
A tenth of a millimeter is fine. So you make two slits in a barrier, say a tenth of a millimeter apart, and then you aim your laser at it, and the result, and then you project that picture on a screen a few meters away, and you see that instead of just getting a shadow of two slits, or of one slit if the resolution weren't enough, you get an intricate pattern called an interference pattern. And it's the same pattern that you would get on a different scale if you put a barrier in front of some water waves. So water waves also don't produce a shadow in the water, but they produce a complicated interference pattern. But now you can put a filter, a dark filter in front of the laser until only one photon is going through at a time. Now this you can't do at home, but you can easily do it in an optics lab with a photomultiplier to detect the light. And you find that even when the light is going through one photon at a time, and so you only see it on the screen going blip, 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 it still goes blip in that same pattern, identical pattern. So there are places where it sometimes arrives, and there are places where it never arrives. And if you have only one slit open, you also get a pattern characteristic of one slit. Pattern
wait,
characteristic of two
I'm
slits.
so
You can make
dumb.
3 slits, 4 slits. Each number of slits produces a radically
I
different,
literally
apparently,
forgot the level.
radically different pattern. Now, the thing that tells us conclusively that there are parallel universes, wait for it, is that if you look at there are certain points on the screen where photons, let's say you have one slit open, where photons
What?
are arriving, and if you open the second slit, they stop
God.
arriving there. So, how come? Well, obviously, they must stop arriving because they know that there are 2 slits open now and not just one. And if you look at the mathematics of this, what determines whether they arrive or not depends on how many slits are open. 1, 2, 5, 17, they all give a different pattern. And the mathematics tells us when opening a new slit will stop light arriving at a given point.
So to be clear, we're still talking about firing one photon through the same slit as before.
Yes.
It's just that because we've opened up another slit now,
Yes.
suddenly that photon
God.
just isn't going through that slit in the same way as it was before.
Exactly. So then we can do various kinds of experiments. Something must be coming through the other slit. Something which stops our photon, the one we see.
What?
Finally, or the
Right.
one which our photomultiplier detects. So we can do various experiments. Some people, at first, you might think, well, maybe when it comes to the slits, the photon splits in 2, and then they join up again before they reach the slit. Well, you can do experiments to show that isn't the case. That you can never detect half a photon. You can only wherever you put the photomultiplier between the laser and the slit. If it's going through one photon at a time, then you only ever see one photon or none if you put it somewhere where the photon isn't. It's only ever one
my
or none,
God.
never 2, never more than 1.
Right.
So then you can say, well, maybe there's something else invisible going through which we can't
Oh
detect.
my God.
Well, what? So you can do experiments on the other slit. Whenever you detect a photon, you also look at the readings for some other apparatus you put in the way. And you can put, for example, a prism in the way. You can put mirrors in the way so that whatever's going through the other slit might bounce off the mirror. And you find that if you make it bounce long enough, you get the one slit pattern again. Because the thing that came through the second slit does not arrive too late to affect the photon we see. And then because the formula for what happens depends also on the phase of the photons, you can put a glass filter to slow down the photon just a little bit, and that actually shifts the pattern because the first photon is arriving slightly before, but not long enough before to be unaffected by the second photon. So the thing, in short, the thing that comes through behaves like a photon. It's deflected by mirrors. It's half deflected by half silvered mirrors. It's affected by prisms in exactly the way a photon is. It's just
that is to say, in the way that a particle of light would behave.
Yes. Yes. So at these very small amounts of light, it always is emitted as particles. So it's always the photomultiplier detects the particle, and if there's less than a particle there, it sometimes detects and sometimes not. But when it does, it's always a full particle.
Sure.
So it is light. It's just invisible light. Well, what does that mean? Well, you can do experiments with the energy and find out whether some of the energy is given to the other photon, and the answer is no. and so on and so on. And the conclusion is that this photon exists always in multiple copies. Even one photon exists in multiple copies, of which we can at most ever see one. It's you might ask which one. Well, that's like asking which identical twin am I. There are identical twins. When we look at the screen, we're seeing one of those photons, but there's another instance of us seeing each of them.
Yeah. Okay. So let's slow down a bit here, because this is really important. So typically, when people describe this double slit experiment,
Will I be able to?
you're firing a photon of light, a particle, through these slits, and it's acting like a particle.
Oh my god.
Everything you do to it makes us think that this is a particle that we're
Which
dealing
just means
with. And
it's
yet,
localized. It doesn't spread out more than...
Right.
Yeah.
Like a buffer almost.
yeah, so it's this tiny little thing,
Yeah.
and yet
This first click.
we have sort of contrary information
This is
that
gonna fucking kill
this
me.
particle is also acting as if it were a wave. Interference
Oh my
patterns being
God.
sprung up on the screen behind the slits. You know,
Okay,
it seems to be coming out, sort of going in as a particle, coming out as a wave.
What is that
Depending on
last
what
vibe?
you do with it and how we look at it, it either acts like a particle or as a wave.
We only ever see the whole pattern
What?
in one go, like we do with water waves. If we send through lots of photons
Alright,
at
this
once,
is 4 frames.
so that where each one comes out is kind
This
of
is
blurred.
bad, but not too fucking bad.
Yes.
When we
Please.
send through one photon at a time, then what we see is blip, 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 just across the screen. By the way, I say blip, blip. This tells you what one photon at a time
No.
means. Like if the blips are 1 second apart, then the actual photons are 186,000 miles apart. You know, there's no way they can affect each other like successive photons can affect each other.
Right.
So this
right.
is a single particle phenomenon.
Yeah. Okay. So this is confusing. Particle, wave, what's going on? At the time that this experiment is
Billions of
first,
frames
that
to
this result
click.
is first discovered, what's the first reaction of the scientific community as a means of explaining what's going on here?
The first way of coping with this was
What?
before this. Well, actually, I was going to say before.
I
before
cannot-
many people
I don't
knew of the
understand.
photon type experiment. It had actually been done by a guy called G.I. Taylor in early 1900s, but he didn't see the significance of it. So the first thing that the mainstream physicists thought was that the particle was a wave. It's just a wave going through, and the only reason it's only seen in a narrow range of places is that it's a wave packet.
I forgot.
It's like if you
This is terrible! This is my skill
you're
issue!
kind of making a wave in it. You can either make a wave that goes along the
How?
If you suddenly move your hand, then a single, called a wave packet, moves along the skipping rope. And
Yeah,
that-
like a
my
little wave will shoot all the way down the skipping rope.
Yes, a little wavelet, you can call it.
Yes.
And it carries energy. You know, the person holding the rope at the other end will feel the kick.
I'm here!
Sure.
So it was thought that the first thing that was thought was that maybe light is like that.
So
And by the way, later they did
like-
experiments to show that electrons and neutrons do exactly the same thing. So
What?
light, what had been thought to be a wave for about 100 years before that. So, but electrons and neutrons had been thought to be
forgot.
particles. But when these phenomena were detected, identical phenomena were detected, then people say, well, maybe all particles are actually waves.
And so a photon would be something like light is a wave, and a photon would be something like one of these little wavelets,
Yes.
just being sort of shot out one at a time. So what's wrong with that interpretation? Why can't we think of photons as just tiny little waves?
Well, there are several things, several weirdnesses piled up. And the first one, which is perhaps not the most important, but since you seem to want to go back to these early interpretations, the first thing was the photoelectric effect, which, by the way, Einstein discovered why it happens before real quantum theory was invented. It's kind of an early form of quantum theory. The problem there was that, you know, the photoelectric effect is just that when light hits a photoelectric cell, like you use to, you know, open an automatic door when you approach, when the light beam is interrupted, the electricity becomes less, and so on. When you put brighter light on the photoelectric cell, you get more electricity. When you dimmer light, you get less, until there's some threshold below which, no matter how much
I used to be so good at this UFO.
Put on the photoelectric cell, if the energy of each photon is not enough to excite the cell, you
I
get
forgot.
nothing.
There's
So
a
it's
timing.
not dependent on the total energy incident on the photoelectric cell. It's a matter of the frequency or the energy of each photon. So that tells us that photons come in particles. That, you know, photon-ons meant it was a particle, and so that was Einstein's theory, and they gave him the Nobel Prize because, for various nasty reasons, they didn't want to give him the prize for relativity. So, so that he got the prize for that. But later, there were experiments with. First of all, there were experiments with silver atoms, Stern and Gerlach, where you had silver atoms not going through a slit, but being split, a beam of individual silver atoms. So we're going to talk about one silver atom, and it's got a intrinsic magnetic moment, so that when it's hit by a magnetic field, it's either pulled one way or the other. Or you might think, if it was at an angle to
That's
the
an extreme
field,
demon. There
it
is
would
no
go
earlier or late.
slightly
There
to
is
one
only.
side. But it doesn't.
fucking
It only ever
down.
goes fully to one side or fully to the other side. And so the spin or magnetic moment of a silver atom is also quantized. It also can only exist in 0 or 1 or 2 units, and so on.
I thought it was that.
Then you can put a magnet after that.
Maybe this shit fucks
So
me up.
if you shine them through, individual silver atoms, you'll find them going blip blip just in 2 different places. Blip 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 blip, randomly apparently. And then what you can do is you can put another magnet with the other polarity to make the 2 beams. And let me stress, these are beams. One of them has got nothing in it. It's a silver atom and a silver atom in another universe, actually, but they didn't know that. But you put a magnet in the other direction to bring the beams together, and then you find that
what am I doing?
the state of the silver atom is what it originally was. I should have said, if you want it to go randomly up and down,
Fuck this level!
Started off pointing sideways. So you classically you'd think that if it starts off pointing sideways, it won't be affected by the magnet at all. It'll just go straight through because it's like pulled equally up and down.
Pulled in
but
each
in
direction.
fact, it gets split always, no matter what direction you push it. You put it in sideways. It goes through this thing. You put the magnets the other way, and then it always emerges in the same direction it started out with. So it knows. It knows that it was once a leftward pointing rather than upward or downward pointing. But if you interrupt it halfway through, you'll get an upward pointing or downward pointing randomly. So that was the next thing that puzzled people. And at this point, they knew that something really weird was happening, because a lot of them had predicted that this thing won't work with matter. It'll only work with light. And,
Sure.
And
Sure.
the silver atoms were the first thing that they tried that wasn't light, and it worked exactly the same, and the equations were the same, and the experiment was the same. And then finally, now this wasn't an experiment, it was a piece of theory that had to do with the description of the experiment, including
Oh my god.
the experimenter. If you think of a particle as a wave, then it's a wave in 3 dimensions. It's moving along just like the blip in the skipping rope, or the blip in a water wave, or whatever. But the mathematical description of 2 particles, possibly interacting with each other or not, the real description is that its a position is this in one universe, and that in another universe, and this in one universe, and that in another universe. And so to describe
So 2 3-dimensional spaces.
Yes.
I see. Okay, so I'm beginning to see where we're getting sort of multi-universes jumping out of this kind of stuff.
And so the next thing, which was I think the final clincher, was really invented by David Bohm, who interestingly invented an entirely new interpretation of quantum theory, which tried to get away with not having parallel universes. But I think his interpretation is really the Everett interpretation in a state of denial. It's very, very weird and counterintuitive, and involves lots of things that we don't see, and so on. But anyway, he had the idea of why do this thing with 2 3-dimensional particles? Why not just use spins again? Why not have 2 spinning particles, and the spin of one particle can only take 2 values up, or like when it can only be measured to have one of 2 values, and the other one also. So the combined system can be in one of 4 states, and you can make them interact, and indeed you can predict that they will behave, each of them will behave as though it were affected by both instances of the other one. And that is quantum computation. So they didn't call it that, they didn't think of it as that, but that's what it is.
Sure. Okay, so let's rewind a bit to this double slit experiment.
Yes.
And can you tell me about other, I mean, I'm hesitant to use the word interpretations now, because you seem to think that these are better described as copes.
Yes,
as
or at least other theories, which are unthinkable.
The Copenhagen, I suppose, with emphasis on the cope.
Nice.
I'm wondering if you can talk us through what that interpretation is, and why you think it's insufficient.
Why I think it's not sufficient.
Yeah.
Yes. So
I've never tried to this during my first session.
2 different things are called the Copenhagen interpretation, just to be complete about this. The original one is hardly ever advocated. That was advocated by Niels Bohr, and it said that quantum theory only ever applies to microscopic things, and that macroscopic things have to be described informally, not by theories of physics. So you can see why physicists didn't like that, but it also doesn't make sense, because by its inherent mathematics, quantum theory applies to things on all scales. So the best way and then there was the wave function collapse theory, more or less invented by von Neumann in the 1940s, which says that when you observe a photon in one place, the other copy of it disappears. So it really doesn't solve the problem, because if the other copy is macroscopic, that you still have all the many universes implications, like when there are 2 to the n of them, there's still 2 to the n different things which are all there until you observe the particle.
I
and then
don't
all
get
the
it.
Well,
theory
this
at
is the interpretation. This is the interpretation that I'm most familiar with, that I was probably taught at school. That when we look at when we look at sort of a wave, we're seeing this wave function of all a sort of probabilistic distribution of all
Yes.
of the things that a particle can be doing, and that's what we're observing. But when we observe the particle, everything else just sort of disappears, and suddenly the particle is
Yes.
in one place. Now, I remember the first time I learned about this thinking, that seems absolutely absurd, but it was what was being taught, and I thought
Yes.
it was just one of those things about quantum physics that's just amazing and counterintuitive that I'm just going to have to swallow.
Yes.
But that's not the case.
No, it's not. It's worse than counterintuitive. It just doesn't make sense. It's nonsense. And the classic way of seeing that it's nonsense was invented by Eugene Wigner, yet another physicist, who
Shit.
also, this was a long time ago, but he also didn't accept Everett. But nevertheless, he invented what's called the Wigner's friend paradox, the paradox of Wigner's friend. And it's not a paradox, it's an argument. Only he thought it was a paradox. But the argument of Wigner's friend is,
Right.
supposing that you have a friend who's a quantum mechanical object. Now, we can't do this experiment in real life because we can't control the positions of all the particles in a human being to find the details as we need to do an interference experiment. But suppose we did it, then the
What?
friend was observing the strange
You're
Earth.
so dumb.
So he looked to see whether the silver atom was in the upper on the upper path or on the lower path, and when he looked at it, it would jump to being in only one of the paths,
One or the other.
and he also, because until the jump occurs, there's going to be two of him as well on a microscopic level.
Right.
So suppose you look at him, but you don't look whether it's on one path or the other. You look to see whether it was left or not. Just like on the final screen, you can see whether you can choose to detect whether it's up, down, or left, right, just not both.
Let me try
So
something.
on your friend, you look to see whether his consciousness is registering left
Yeah, that works.
or up or down
Again.
or what? Sorry, no, you can't do that. Registering left or right, sorry.
Yeah.
Yeah, let's do that
And
together.
whichever of those you see, it will spoil the up-downness.
That's cute.
So,
Fuck.
I'm not explaining this very well, but later I proposed an experiment which would in principle be possible, but instead of Wigner's friend, you have a quantum computer. Let's say a quantum computer running an AGI program. So
Right.
this quantum computer is a physicist, and it's your
Yeah.
friend, and it decides that it's going to do this experiment. And halfway through, when it's looking at the up-down thing, it will sign an affidavit, signed and sealed by a notary public,
Yeah.
or whatever, and it will say, I, Mr. Quantum Computer, certify that at this moment I am detecting either up or down.
Alright, this is...
I'm not detecting
Again.
left to right or both or anything like that. I'm seeing only one of up or down. I'm not going
Yep.
to say which, because if I said which, that would propagate to whoever reads this. But since I'm not saying which, anyone can read it and it won't spoil the experiment. So then, again, instead of the experiment where you put the magnets up the other way, he simply reverses the dynamics of the memory element in his brain in which he remembers whether it was up or down, but not the one where he remembers that he saw up or down.
Yep.
So
No way.
then out it comes, out of the quantum computer, into the detection magnet at the end, and it detects that it's sideways. So in other words, what he did not collapse the wave function.
This fucking level.
And yet,
Right. So the computer has observed whether it's has observed the actual position,
yes,
which you might want to think would collapse this wave function.
yes,
But then what the computer forgets what position it saw the particle in, but doesn't forget that it saw it in one or the other.
yes,
So something has observed where this particle is, whether it's up or down.
yes,
It's observed it, and yet when it comes out the other side, it's still, to us, observing the whole system,
No.
not up or
one
down.
frame.
yes. In fact, it's
Artillery three.
certifiably what it was before it went in.
That's
Right.
sad.
Which means that this computer has observed the particle without collapsing the wave function,
Yes, exactly.
which tells us,
Well, if that happened, that would tell us that the wave function doesn't collapse. If it didn't happen, it would tell us that quantum theory is wrong, and therefore that Everett is wrong.
gotcha,
So
gotcha.
it's a test. It's a crucial test of Everett
see.
against all the other interpretations except Bohm.
Interesting. That's fascinating. So okay, so people are going to be listening to this, and it's a lot, and I'm certainly no physicist, so I might not be picking up on the right bits here, but hopefully people are following. But they're going to be.
What?
Okay, we were talking a moment ago about
I even
the
voice cracked. I
multiverse.
never
We
knew
were
this was
talking
a
about this
possibility.
image in my head that, every decision I make, there's a version of me somewhere else that's doing the opposite and ever expanding into these uncountable trillions of universes. And now we're kind of talking about firing silver atoms and seeing whether they're up or whether they're down, and getting a quantum computer to have a look. And how does this all sort of dovetail together? Where do we go to get from wave collapse of the wave function view of what's going on here is false to multiverse?
No, we made
Well,
a bit.
collapse of the wave function
I've
is
been
only
messed up.
one of the possible copes. So what we're really testing is Everettian
we
quantum
miss.
theory against any theory that has only one universe.
Shit.
Any theory that has only one state of the silver atom, the observer, the rest of the world, the scientific paper he writes, all the things that could be affected by whether the observation went up or down. Those are all affected or not in this experiment, and
Sure.
In that sense they are universes. I mean, the other way you can see it, the more usual way of seeing it, is just that the same equations apply no matter how many particles there are there. But to the layman, that may not be as convincing. So it's that it's going to affect things. The differential position is going to affect things differentially that are affected by it. Note that therefore, in one sense, the term parallel universe, the term universes is rather misleading, or it can be misleading, because the only things that can be affected are the ones that are actually hit by a photon or a silver atom or whatever, and those travel at most at the speed of light, and therefore this splitting or striation of reality into multiple realities doesn't go outside a sphere, an expanding sphere. And in fact, most of the things in that sphere are not affected anyway, so it's only certain things in the sphere, but nothing outside the sphere is affected. So it's never a universe that splits in two. It's only ever a piece of the universe that has some traveling information in it that split in two.
So what's the best way of picturing this in our heads? Because when people think of a multiverse, they might be thinking of lots of sort of orbs, and each orb is its own universe, and they all exist in some kind of void or something, right? That's not quite right here. Like, how should we be trying to picture this in our head? Is there a good way of doing that?
There are many reasonably good ways, perhaps none perfectly satisfactory, but so first of all, if you think of the multiplicity of the multiverse, it's best to think of things not splitting in two, but of two things which were originally identical becoming different. So things in the Stern-Gerlach experiment, things which were originally universes or silver atoms, which were there were lots of them, and they were all originally pointing in one direction. And then when the magnet happens, they differentiate themselves.
My finger got fucking liquid, but it is not a fucking excuse. I'm not supposed to die to this UFO whatsoever. I never did so during my first fucking session of playing this level. This was the most free part ever, and today my hand is trembling. For no reason.
They can rejoin, and the up and down universes interact with each other to produce a left or a right. Well, let's say it started off left. They will reliably produce a left universe again. And so the universes become identical again until something splits them again.
So it's sort of like one big universe, one big space in which multiple kind of I don't know what the word is here. Like if universe, the word universe obviously is multiple branches of events are sort of all intertangling and interacting.
No.
These aren't sort of completely mutually exclusive universes all existing side by side, but these you know, probably not actually infinite, but you know, infinite in the sense of in the rhetorical sense of being sort of uncountably huge numbers of branches that interact with each other, and this multiverse is an interactive multiverse that we're thinking about here, right?
Yes. This rejoining, as I said, is very difficult to arrange, and it only happens in very specialized circumstances.
Such as the one we've just talked about.
But on the microscopic level, it happens all the time.
Fuck you.
In a chemical molecule, a benzene molecule, I think, is one of them. You have electrons can be either above the plane of the 6 atoms or below the plane, or both at once.
No.
In different universes. So this both at once state is stable.
So can we go back and basically run through? I mean, a moment ago we talked about the double slit experiment. It's the one that most people are familiar with. And we explained what happens there. Can we go back and can you explain it again, but this time in explicit terms with reference to this many worlds interpretation of quantum mechanics? What's actually going on in that experiment? What's happening in your view?
So we release one photon per universe, per Everett world. Actually, that one universe, that one photon exists in a swathe of universes. The swathe of all universes in which we did in fact release it. There'll be other universes in which we didn't release it, and so that will not contribute.
I cannot believe I'm so bad.
There'll be a swathe of universes in which we release the photon, and in all of them, it will go towards the single slit or double slit or whatever we put there in front of it. In some situations...
Well, actually, maybe technically it's possible, you know, to buffer the slit and jump from here there.
In the case of one slit, there will still be interference because photons that touch the left side of the slit will interfere with photons that touch the right side of the slit, because that will make them different from each other. And they will then, and that's why there's an interference pattern even with one slit, but it's smaller and less pronounced than
because some of these photons are sort of bumping up against the side of the slit.
Yes. So physicists of old called those different kinds of diffraction, but we can just call it interference. It's kind of interference. When there are two, they differ by more. Their phases differ by more, and so they have a more pronounced effect on each other when they are rejoined. So then, so they come out of in the two universes or two branches, because each branch consists of a whole swathe of universes itself. But in the two branches, in the first branch, it comes out in a sort of little cone, and the other one that comes out also in a little cone, but displaced sideways from the first one. So these ones are displaced by, say, a tenth of a millimeter from each other. So, I mean, it's big enough to see. It's not that microscopic. And then they travel at the speed of light towards the screen, and when they're reaching the screen, the ones which head away from each other don't
I
do
thought
anything
that
special. But the ones which are heading towards a given
I
point
thought that
where where light can reach that
I
point
thought very
from
much for
both
my own
slits.
good. That's what's happened.
Right, not all points are like that. You know, if you go
Yep.
far enough sideways, if you have a point where light can reach from both slits, the photon in one universe will interfere with
Yep.
the photon the other universe in such a way that it either stops it getting there, deflects it to somewhere else, or it doesn't. And if it doesn't,
Well, how are photons from different universes interacting with each other in this way? How are they sort of bumping off each other?
Sort of. So the universes, as you said just now, the universes are in constant interaction with each other. It's just that most of the time, things we see, it all cancels each other out.
Oh my god.
And we don't see interference phenomena. But if we look at things in theory, we see that there are
Can we do that
interference
together
phenomena
too?
all the time. Solid matter is an interference phenomenon.
Alright, we can't.
Well, when we try to display an interference phenomenon in the laboratory,
That'll be
we're trying to display something that can only be explained by interference.
Stop.
So we know that solid matter can only exist because of interference. But
So what do you
solid
mean by
matter
that? So solid matter can only exist because of interference. How do you
Yes.
mean?
So
my
the
God.
individual atoms in a
This is so
in
terrible.
say in a crystal
Yep.
I thought it was dead.
are in this lattice, and if they were
Fuck.
interacting with each other by classical electrodynamic fields, as was thought before quantum theory, then
Fuck!
the whole thing would collapse into a sort of puddle.
What?
There isn't enough of a potential well.
I clicked so early!
There's no potential well at each point to keep the atom there. What keeps it there is that it is in more than one place at a time, and so are all the other atoms. They're all in more than one place at a time. And this state
I
of being in
felt
more than
that I
one place
messed
at a
up.
time, just like the silver atom in this Joan-Gallac
I
experiment,
clicked so early.
being
And you're telling me I'm late.
on the up path and the lower path at the same time is equivalent to pointing sideways, which is the thing that can't be expressed in just being up or being down. And in a crystal, it could be that this other way of being, a way of being in this place and that place at the same time, has a lower energy than either of them separately. And therefore, the crystal settles into this lower energy state where the particles are no longer in individual positions.
No, I forgot
so
that
that-
there is some
because that's
sort
lower
of
energy,
timing.
It requires energy to change the shape, and that's why there are solids.
So we
Fuck.
require a multiverse in order to get solid matter.
Yes.
This
What
seems
can
to
I
me
do to avoid
like
this?
a revolutionary claim, and yet you were talking about it earlier as if it's obvious, and you can't understand why scientists are unwilling to accept this. But you understand that on the face of it, that seems like an extraordinary claim to make.
Yes, I don't think it's as extraordinary as relativity.
Fuck.
For some reason, it's resisted more. And there are different kinds of copes. I mean, there used to be copes in regard to relativity as well, but they were of a different kind. Maybe I should say one thing that is very convincing to physicists is that
Alright.
when you actually use the theory, you have to write down the equations, and you can either not ask what the equations are saying happens in between the initial state and the final state, or you can ask. If you ask, you have to talk about other universes. For example, when you write down the equation that takes
My finger, what did you do?
light,
What did you do? What
from
did you
a
do to my
laser to
in-game
a
character?
15 slit barrier, you have to write down 15 equations, one for
I
each of the slits. Sorry, an equation with 15 terms. Sorry, a single equation with 15 terms in it, and nothing less will do.
Fuck.
And this is again why quantum computers are important, because that means that quantum computers
Fuck.
can do computations which involve 15 or 2 to the power of 15 separate computations, which are then brought together to give an answer.
I forgot.
So
I see.
if you're a quantum computing person and are inventing algorithms for quantum computers
Fuck.
to do difficult tasks, you have to work out what each one of those 2 to the 15
Fuck.
branches will do. And there's no way of getting around it. In fact, for the interesting cases, there is provably no way of getting around it. So you know that the whole reason why you want the quantum computer to do this is that no way of following through individual paths, or probabilistic individual paths, or individual paths with collapse,
Fuck.
or whatever. There is simply no way of getting the answer in less than whatever it is, 2 to the 15 pages or 2 to the 500 pages, whereas the quantum computer can be run and can do the motion referred to by those 2 to the 500 terms in the equation all at once.
Right, because it can sort of those,
Fuck.
and that's because those different terms all represent different, say, branches, rather
Yes.
than to not use the word universe. They all represent different branches, which a quantum computer is able to actually just sort of have coexist and interacting all at
Yes,
once. Whereas
that's
any human
exactly right.
being looking at any of these terms is suddenly going to be
No, it is not 1, 2, 3, 1, 2. It is 1, 2, 1, 2, 3.
to look
Fuck.
at the whole system of branches interacting all
Yes.
together, and that's what quantum computing will do for us.
Yes.
And how far off are we from this technology really becoming something that's
I don't know.
usable?
I haven't been working on quantum computation for about 10 years, because I've been working on constructor theory using with my other hobby horse, so I'm not familiar with the state of the art. Every so often there's a new idea, and I think, oh, now it's going to work, but it's extremely hard. And the reason it's extremely hard is that any kind of perturbation of the quantum computer, while it's
I cannot believe! No, it was so free.
will make only some of the universes different, and the others.
My
will
finger just does not
maintain
feel
all the
comfortable. I
universes.
don't know why.
So you've got to either prevent the perturbations happening. or you
Yes,
can do
those
this
clicks
method
are
called
tight, but not 4
quantum
frames
error
tight.
which is a kind of quantum computation, that specialized kind of quantum computation that removes the errors. It's like a error correcting code, except that in classical computers,
Well,
an
that's
error
everything.
correcting code always involves
I was
redundancy.
playing from 51, so
where, let's say a majority vote is taken. You have five bits doing the same computation, and if one of them is different, you reset it to what the other 4 are saying. In quantum computation, you can't do that, because to detect that one of them is different would be a classical computation, and that would spoil the interference. But fortunately, there are quantum algorithms that do the same thing, that can internally detect, without ever telling you They internally detect which qubit was different from the others, and they change it accordingly.
What?
Which one was wrong?
This was never a
I've
thing.
gotta say,
That was
this
never
all
a
still
thing.
sounds- I mean, this idea that we've got multiple universes interacting, multiple branches interacting,
Yes.
and I understand the idea that when I observe one of these branches, it's kind of just like finding out which branch.
What?
Yes.
It's not like a wave function collapse. It's just that I find out which all of the options do actually happen. I'm just
Yes.
finding out which one I'm in. It still seems strange to me though that if I don't make that observation, then at the end I can look at the whole system as if
Alright.
all of the branches sort of all happened in this one universe. You know what I mean?
Well, because they're all the same by then. So you're still only seeing one of them, but they're all the same. So like the silver atoms in the Stone-Gallic experiment.
Yeah.
For a while in the experiment, they're doing different things.
Wow.
But by the time they come to the end, all the universes, or both the branches, or
No
however you want to
fucking
put
way.
it, are identical. They are both pointing to the left. So no matter who looks at it in what universe, they will see something pointing to the left.
So why does our observation of an individual particle in the double slit experiment change from change the end result from an interference pattern
found it.
into two singular slits,
In
two
the-
singular lines on the screen
Yeah. So in my
in
thought,
the many worlds interpretation?
yeah, in my thought experiment, it doesn't change it, or at least it
What?
if you perform the experiment as specified, because you're bringing the branches together again.
I
the
forgot
key step.
something.
Now, when we
Right.
look
Fuck.
at that in real life, we can't bring the branches together again because that would involve sort of a massive 10 to the 26 pronged magnet,
Fuck!
converting us back to the same state that we were at the beginning, other than having remembered, and all that stuff. So it's not feasible to do that with an actual human, but it is feasible to do it with a quantum computer. By the way, you said just now there are the universes operating in a quantum computer, and then I think you changed your mind and said branches. Branches is much better, because especially in a quantum computer, the rest of the world isn't affected. If
Yeah.
it were, the interference would be spoiled. So the
What?
inside the quantum computer, and then gets undone.
Stop dying to the
before it
UFO.
presents its results.
It's not hard. Never
Yeah,
was.
so I think
Fuck.
that's actually a really helpful way of picturing what's going on here. Like if you, I mean,
Stop.
when I think of a computer, I'm thinking of like a big sort of plastic box, and it's all happening inside of there, and there are these sort of multiple universes, so to speak, but it's everything outside of that box is completely unaffected.
Yes.
So it's branches within one universe, and the trick is bringing the branches back
I don't
together.
know why this
Yes.
happens.
So in the
Why is
double-slit
that, like,
experiment,
tricky?
The reason why we
I don't
get
understand.
different results is because by observing one
Fuck.
particle and which slit it goes through, we
Stop.
have found ourselves on one of the branches,
It does-
and that
Yeah.
branch is never going
Fuck.
to rejoin the others again.
Fuck!
But if it did,
Whereas
by some
if it did,
amazing-
then we would still be able to
I
observe
fucking
that one particle and have it come
hyper-focused
out
on
as
the
an interference
previous
pattern.
and one of the
Yes.
previous clicks.
But because that's unfeasible, that's not something that we're really going to see happen. And the
Yeah.
reason why we end up getting the interference pattern
Fuck!
is because when we don't observe that particle,
Fuck!
we don't find out which branch we're on, and those branches come back together
Fuck!
to produce this interference pattern on the back of
Are
the
you
screen.
fucking
That's
serious?
exactly right. Though again, just because people will misunderstand this, it's not a matter of finding out. It's a matter of the information. It's a matter of us having differentiated the different versions of us, which are always there. Would if the information works out, then we would have differentiated into people who see one configuration and people who see another configuration. And then you could only get the right answer from the quantum computer
Stop!
if you brought that information back and erased it from everywhere it had got to, or made the did something to make all the different versions of the observer identical again.
So everything happens inside of the quantum computer, and the exterior world isn't affected unless we observe which branch the quantum computer is on.
This is so
Like, there are
unlikely.
multiple versions of me created.
Why did this happen?
Yes,
Which observes
I did
one
not
branch of
mean
the quantum
to-
computer,
We don't
one
actually-
which observes another.
You
Stop.
actually have to do the observation. It's enough.
That does not. That didn't look late. This
hits the
didn't
qubit
look early.
location.
Right.
So that
Why
if we
was-
observe- that it's already, the interference is already
Why
spoiled.
were those like that?
That's
Yeah,
why they have
Fuck!
to. Yeah, it's too late. So it's not a matter of.
So it's not the observation that makes the difference.
Yeah.
It's something
That
else that makes
wasn't
the
early.
difference, which observation necessitates.
Yes, which would permit observation, but whether the observation actually takes place is irrelevant.
And what's the best term to use to describe instead of observation there? Like what
This
is
is
the
not.
thing that happens? Which,
It's called decoherence.
This is not.
decoherence.
Yeah.
I thought it was
And
that.
if you had to sort of summarize the definition of decoherence into a
It's-
sentence or a couple of sentences.
It's where some other physical object, like an air molecule, let's say, or an oxygen molecule in the air, hits a qubit and becomes differentially affected by whether the qubit is up or down. After that,
Now-
there are two versions,
Fuck!
for the oxygen molecule as well, unless you can make it come back and undo that phenomenon, undo that collision.
Go fuck
the phenomenon
yourself.
won't happen.
That is
Which
not
is
a
possible in
death.
principle, but far from possible in practice.
Yes. Although you can do quantum error correction, which is kind of magic.
What?
It's almost the same.
What?
Yeah, I mean it sounds like magic, but then they say that any sufficiently advanced technology is indistinguishable from magic.
Yeah.
Just to close out, what are some of the philosophical implications of this in your view? And the reason that I'm asking you, I don't know if you consider yourself much of a philosopher as opposed to a physicist, but the reason why I think it's interesting to ask you is because you understand this far better than someone like I will, and so when I think of the philosophical interpretations of the multiverse, I'm kind of picturing this, bunch of different orbs kind of multiverse, which you're telling me is not what quantum mechanics is implying.
Fuck you.
Yes.
So what are some of the philosophical interpretations that someone could make of a correctly construed many worlds quantum realm?
Right. Well, the philosophical implication. So, I don't know whether you call this philosophy or
Fuck.
meta-philosophy or whatever, but the whole story of trying to understand what the equations of quantum theory tell us about the world is a story of realism versus everything else. It's positivism, instrumentalism, woo-woo.
This is
you
1,
know,
2,
you
1, 2,
name
3,
it.
not 1,
You
2,
name
3,
the
1,
bad
2. Remember.
It has derailed
Fuck!
understanding quantum physics.
Alright, completion time.
You have to be, and I think this is true of all science, but you want to know what the lesson of the history of quantum theory is, that to do proper science you have to be
I
real
got scared.
and not being and Einstein,
Because
by the way,
the momentum
very
is so high, it's so
was a risk.
scary.
and
It
and
falls
this
down so
picture of
quickly,
him
it's
of-
almost
as-
like
as,
teleportation.
being a stick in the mud
It's
and
so
not
fucking
wanting to accept
scary.
quantum theory is false. He didn't want to accept anti-realist copes, as he called them, for
Right.
quantum theory. He didn't know what the right version was. Unfortunately, he died sort of just before.
Fuck you.
I mean, I think Everett was already producing his theory, but wasn't quite ready. So if he'd lived another few years, Bryce DeWitt says he's sure that Einstein would have switched immediately to it, but we don't know.
Fuck
we
you.
can't tell. So that's one, and also I myself am sure that quantum computation would have been invented at least at least 30 years earlier, if not 50 years earlier. if people had not been if the leading lights of theoretical physics had not been instrumentalist, positivist.
What?
Wow.
Um,
That's a hell of a
20
perspective
frames to
on,
click.
Let's say
yes,
closed-minded thinking.
I think it is a scandal. But now, maybe what you really wanted was not this metaphysical implication, but an actual one. That I think the most direct one turns out to be
Fuck.
not very earth-shaking. The one I'm referring to is, since you know that every
Fuck.
time you cross the road, in some universes you will be killed by a bus that you didn't see. On the other hand, in some universes you will be saved from the meteor that hit your house just immediately after you left it.
Yeah.
So what do you do about this? Should you be risk averse?
I'm gonna fucking die out of boredom.
Think that, no matter what happens
Fuck!
in some universes, there is a mistaken line of thought called quantum suicide, which says that if you're in if your life is going wrong and you're unhappy, what you should do is buy a lottery ticket and set up a machine to kill you in your sleep if you don't win. And so if you wake up, you'll only wake up in the universes where you did win.
Yeah.
And
I see.
that is using the frequency interpretation of probability, which is exactly wrong according to quantum theory. So
I'm glad to hear you say that that's wrong. Tell me why that's wrong. Just in case anybody's getting any ideas listening to this podcast. Tell us why that's wrong.
The idea that probability in the sense of what you expect to happen, and the probability in the sense of if there are many copies of you, or you're many people who you identify with, or whatever, that any one of them has a 1 over n. You have a 1 in n probability of being that one.
Of being that one.
Of being that one. That is a mistake. And it's a known mistake in the philosophy of probability, and people didn't really know what to do about it, but quantum theory solves this. It so happens that there is a structure within the physics of the multiverse that actually is relevant to decision theory. And I was the first one to propose this. It's now been called the decision theoretic approach to probability in quantum theory. And you have to work quite hard to extract the answer. And the answer, kind of fortunately or unfortunately, is that the effect on your decision, knowing that you are in a multiverse, should be exactly the same as it is if you knew you were in a stochastic universe where things happen by chance. So in other words, it has no effect.
If you win the lottery in 1 out of 80 universes, that's not the same thing as saying that you have a 1 in 80 chance of winning the lottery in this universe.
Yes.
Right?
In your universe, whatever that means. Yes.
So is that because the probability is slightly different, or is it because the probability in your universe of you doing that is, either 100 or 0?
No, it's because it's very unlikely, if I can misuse the term, that probability even applies in this situation. For example, suppose that this is done in a hotel with 100 rooms, and they're sealed off, and they're all quantum mechanically sealed off, so that no information could get in or out. And there's a machine that makes an exact copy of you. So let's say you're going to be killed in. Let's say there are 2 copies of you to make it simple, and one of them's got to be killed, going to be killed, then you should act as though there was a 1 in 2 chance. So the mistaken theory says. But the trouble is that
Fuck.
if you know that you're never going to be let out of this room, as is the case with universes, then you could. What's the cost? How much would you pay to have a copy of you made in another room, which was an exact copy, and therefore it would behave exactly as you did for the rest of your life? You might say, well, that's zero because that will not change any of my experiences.
It's totally irrelevant to me. Yeah.
Totally irrelevant. And yet,
Because it's not me in that room. It's something like a copy of me.
yes. Well, yeah. Now you've said it. You see, because if one of those is going to be killed, you're going to say that there's a 2/3 chance now that the one which we're talking about was going to be killed, and only 1 chance that he isn't. And yet, you're indifferent to whether you are
I
duplicated or
cannot
not.
believe this.
So
Yeah. So
That
the
shows-
versions of you that exist in different universes or different branches within the universe are not actually you. You're not identical with them.
It's
They're
so wide
just sort
open.
of another person that happens to share the same, I don't know, like
Yes.
the same sort of set of atoms working in roughly
Yes.
the same way. And so
You
it's,
might
so it's
say-
wrong to think of this natural interpretation of the multiverse that, oh well, if things go badly for me today, it doesn't matter because things went well for me in another universe. That's not really you.
well, so it's an interesting philosophical question.
Fuck!
The number of them is not the probability of being them.
Fuck!
Gotcha. Yeah,
You
yeah,
might-
no,
you might-
I think that makes
yeah.
sense.
Yeah.
I did want to ask you about one more thing that's just come to mind, which is, I think it comes from Nick Bostrom. He wrote a paper, and it was, I can't remember the name of it, but it was something about how the multiverse undermines consequentialism as an ethical theory. An ethical theory which says that the thing that matters morally is what the consequences of your action are. So take utilitarianism. What we want to do is maximize pleasure. If there really is an infinitely branching set of universes that anytime something could happen differently,
This
it just sort
is
of does
fucking
actually happen differently in 2 different
ludicrous.
branches or 2 different universes. It seems to suggest that if I cause suffering in this universe, there is another universe in which I didn't cause that suffering. If I cause pleasure in this universe, there's another universe in which I didn't cause that pleasure. And so across the whole system, it seems like it doesn't matter what I do, because any effect that I have on any set of consequences, so maybe the amount of suffering in the world, is just going to be equally and opposingly matched by
Fuck
another
me!
branch in which the exact opposite happens. And so if our moral commitment is just to maximize pleasure or minimize suffering overall, then as soon as we accept that there's a multiverse, suddenly we just have moral license to do whatever we want, because anything we do doesn't affect the overall balance of suffering in the
Yeah.
universe. It just affects the amount of suffering in our particular branch.
Yeah, so so many things come to mind. First of all, this isn't an argument about consequentialism. It's about utilitarianism. It's about the idea that we should make decisions according to some kind of calculus of good or bad. And as Popper has pointed out, suffering and pleasure are not the reverse of each other. Because, as he puts it, suffering, other people's suffering, for example, makes a moral claim on us, whereas other people's pleasure does not. We don't have any kind of you might argue about how much claim it makes, but we don't have the same kind of obligation to give somebody
Yes.
more pleasure as we
Deserved.
do to give them less pain.
Looked everything past
Yes.
the UFO.
So that's one reason why that
This is not too good.
story of
But not
Bostrom's
too bad
isn't
either.
right from the get-go. It's
Took me like
then
1 hour.
Remember that the branches
And the previous session I played half an hour
exist in
probably.
different amounts. It's not just that different things happen, that all the possible things happen. It's that different things happen in different branches, and in some situations, some, not all situations, those like thicknesses or weights of the branches should be treated as probabilities, and in some it shouldn't. So if the utilitarian calculus applied, then you would expect to want to maximize the expectation
I'm happy
value of
now.
the total good that you're doing.
Yes. Are you also happy?
On Popper's
feel
criterion, you'd
good
want to
about myself.
probably minimize the total amount of harm
Anyways.
you're doing.
Yeah.
Oh yes,
Miserable.
I remember what the argument is. Now these branches in which different things happen are changing according to
Alright,
the
no, my hand is...
decisions according to
my
many
hand
decisions that we
is
make
trembling.
sequentially.
I need a break
And in particular,
before...
our thinking, creative thinking or rational thinking, depends on error correction. Therefore, there are branches which become alike because our thinking applied to both of them says that this version is better than that version, so we change that version into this version. Now this isn't talking about quantum interference, because we are decohering all the time. So the branches aren't coming together
Oops.
and interfering. They're coming together and just increasing the weight of the branch with that decision. It's as though you looked at the silver atom, but then you manually took the silver atoms and put them in the same slot, where they won't interfere, but there will be twice as many silver atoms in that slot. Similarly, when we decide that a certain thing is immoral, and we switch in the universes where we thought that was moral, we switch to calling it immoral, and the other universe where we thought it was immoral all along will then become broader. It will have more weight, more probability in the situation where applying probability is correct. So this
Alright, that was actually really good.
this calculus is wrong for that reason as well, because we are when we think, when we're making moral decisions, we're not just calculating all the possible outcomes and their probabilities.
Is
We
my
are
hand
changing the
now fine?
outcomes. We're making them. We're making sure that some of the ones we think are bad are converted into ones we think are good. By the way, the same applies to his thought experiment about his allegory about taking marbles out of a jar, if you know that one.
Yeah.
And
Yeah.
they're all white except for a few that are black, and black is doomed. But the thing is, every time you take out a white marble, you change the number of white and black marbles. Every time you take out any kind of marble, you're changing the number of black and white marbles, because you are thinking. And just like I said just now about the branches coming together or not coming together, you're trying to make knowledge better, or you're trying to make the outcome better. Let's suppose you're a moral person. You're
Alright.
trying to make the outcome better. So you're
Something was
changing
wrong
the
with me
possible bad
yesterday.
outcomes into good outcomes.
It only took
In terms of the
30
marbles,
attempts now.
you're
or
changing
40.
some of the black ones into white ones. So it's not like Russian roulette. In Russian roulette, nothing you can do according to the rules of the game. In real life, of course, you could, but in Russian roulette, if you obey the rules of the game, you've got a 1 in 6 chance every time you spin the chamber. But in real life,
Alright, what I need to do now is... I really need to... to go here, I guess.
Struggling with that part.
I should check this level. Fuck, I will get copyrighted anyway. I guess. Anyways.
Struggling with that part.
Let me see the level. I cannot really follow. I cannot really follow in 1x speed. This is for us. But this shit is hot. You just hold and you just hold again. What happens to the robot? No, just orbs. This is for us. This one you skip here, or don't you? Oh, I see. Oh, this is heavy on memory. Does he have LDM on? Yes.
I was like literally no attempts from zero. What the fuck?
Cool. I won't be able to do that. Anyways, I need a 1 minute break. Right.
The outcome depends virtually entirely on what we do, or actually entirely on what we
Let
do
me try this
in the
level
long run.
1
Because
second.
even being wiped out by an asteroid depends on what we do and think now. There's no such thing as the probability we'll be wiped out by an asteroid, unless it's already very near. That probability is affected by what we do, unlike Russian roulette, where it's always 1 in 6.
The probability of whether an asteroid will hit the Earth is affected by what we do.
And think, mostly what we think and then do, yes. For example, for example, set up an asteroid watch and prepare rockets which can deflect the asteroid.
Oh, I see. Right, I see what you mean.
So-
yeah, okay. So it's not. When you were talking a moment ago about, you know, there's a universe in which I decide that something is immoral and I don't do it. Isn't there just then another universe, another branch, in which I decide that it is moral and that I do it? Is there always, in other words, this equal and opposite me that does the good thing and the bad thing?
So
Alright, fuck this level.
there's always a you that does the bad thing, even if that might happen in only 1 in a trillion of the universes. So that is virtually always the case. But it's meaningful to ask whether there are more of you doing one thing or less of
I
you.
wonder which one is
Right,
good.
because the number of branches or universes
Right,
isn't
let's-
actually infinite. If it were actually infinite, then there would be, I mean, like there would be an infinite
Opinions,
number in which you do the
guys.
bad
Are
thing,
there
an infinite
opinions
number in which you do the good thing.
Even
The
then,
quality of the copy.
um,
Maybe not.
if it were a measurable infinity, there'd be.
Yeah,
That's
right.
why I refer to the
There'd be-
thickness of the universes. Even if there's an infinite number in the sense of the cardinality, it would still be meaningful to say that some branches are thicker than others. There's more universes in some universes than others, and in some
Yeah.
there are so few that it's mind-bogglingly few. The English language doesn't have the words to explain how few they are. And in many situations, those thicknesses are probabilities, or should be treated as probabilities. So especially situations where it is a good approximation to think of the process that is choosing one or the other as being random. So
I know. Sorry, continue.
so you may cosmic ray
is
may strike you and
happening
turn you evil. In the overwhelming, in the sense that you
Why
have
is
an
there-
impulse to do an evil thing. In the overwhelming majority of those universes, your values kick in and say, actually,
What's
no,
happening here?
I don't want to do X. So that's turning most of the universes hit by the cosmic ray,
That's a green
which
orb.
happen to cause an evil change in your brain, to turn back to being good again. That's how you think. You error correct. You think. I mean, you don't think that's wrong, so I can't do it. Usually, you would say, "Wait a minute, I didn't think that. That's just a misthought."
I know that this might seem like an impossible or even a stupid question.
What is
It's going to be
happening here?
impossible to know how many universes are implied by the many worlds interpretation of quantum mechanics. But is there a way that you can give us an idea to help us conceive of just how many different universes or branches we're talking about here?
Well, if you think of collisions that happen among atoms, like the ones we were talking about in the quantum computer, most of them, lots of those happen all the time in the world. You know, in all the air molecules in this room, there are many collisions. I don't know how many there are per second,
This
but
level
a
is
very
kind
large
of,
number.
yeah.
And each of those collisions produces a spread of trajectories following the collision, where and they're not all the same proportions in the multiverse either. There'll be a majority, and then there'll be minority ones.
So you
and
don't
there are
click.
some in which, by chance, as it were, or in very few universes, all the molecules in this room are deflected to the other end of the room, and I suffocate.
Right.
So,
Yeah, yeah.
but in most of the ones in which they go to the other end of the room,
So gone.
they immediately come back. There'll be a sonic boom or something, which might in itself kill me. But that's another. You know,
Yeah.
You
there
don't click
is. It's
anything,
not
then
error
you
correction.
click
It's just
those, one click
elasticity
those, and then
happening, which will. And so most of the randomness, or most of the multiplicity of universes,
I hate fucking
is
moving
immaterial
objects.
to the gross outcome. It only is in special cases like a cosmic ray striking a
click
neuron, and
that.
usually not even then.
I guess.
So how
Wow.
many? Well, imagine the number of atoms in the universe, and then the number of collisions that they make, and then the number of possible trajectories from each collision. Then it's
This is so terrible.
first number times the second number to the power of the third number.
Oh my god.
It's very, very, very large, and most of them
I
are,
forgot.
to all intents and purposes, the same. Some of them actually interfere with each other, but there's very few of those as well, because they would have to be a very specially fine-tuned collision to then have another collision, then come back together again.
What?
So, yeah, a lot, in other words.
A lot, yes.
It's
Now,
amazing to think in terms of that equation.
Yeah.
The timesing it one times the other to the power
Do I
of the
really
other.
have to click
Yes.
that?
That's just unfathomably huge. It's one of the problems with talking about
I
this
can
kind of stuff.
really
A lot of
understand.
physics in general is that the same thing happens in astronomy,
You have-
where you hear these numbers, and your brain just can't even be amazed by them because of the fact that it can't even conceive of them. It's one of the many. That's one of the greatest tragedies of our ape brains, I think. that
Why are they
were-
so
were
fucking
built to
small,
deal
those
with,
fucking
having enough
orbs?
food to
I
not
don't think
starve
so.
and not to.
They're
conceive
fucking
of themselves.
I
tiny.
think they were built to understand the world.
That
and
is
we
just
can
fucking
understand
rope dogs
infinity as
music.
well, let alone large numbers.
That makes them so fucking small.
But we can't. It's difficult to. I think Descartes made a distinction between. I can't remember the terminology he used. It was something like conceiving and imagining, and I can't remember which way around he used. But he talked about like take a 125,000 sided shape. You know, you can
I already
imagine it
spent
in
like
the
100
sense that
times I
you
learned
can.
nothing.
You can know true facts about it. You can do maths with it. You can treat it as an object, and you can mess around with it just in your head. But you can't conceive of it in the sense of really seeing it in your mind's eye. You can't imagine that many sides all sort of in front of you. And I suppose there's one sense in which our brains can understand the universe, and that's the first sense, where we can know how many stars there are in a galaxy, and we can do maths, and we can work out the gravitational pull
What?
of each of those, and the trajectory of the galaxy and this kind of stuff. But that's another thing from that's a separate thing from conceiving of it in the sense of being able to really understand what it means to think of a number that large, you know.
It's. I don't think this is anywhere near as bad as you think.
What is this?
That's good if that's true.
I can't really imagine a cube. For a start, you know, if I try to imagine the far side of the cube, then in some sense I'm imagining it as being transparent, but it isn't.
Yeah, sure.
And there's
Right.
I don't know if you've ever been given the puzzle. If you think look at the long diagonal of the cube, and hold it up against the
Oh my
bright light
God.
so that you see only the silhouette.
Yeah, and it sort of switches. It can look like
No,
it's
not
coming
that one.
out.
Okay, that's yet
Oh,
another
right.
one. No, I mean a solid cube. And
Yeah.
you're holding opposite corners of the cube.
Yeah,
the
okay.
most distant corners, and you're holding it up in front of you. Now its silhouette is going to be a two-dimensional shape.
Yeah.
What shape is that? Now, if you ask this question to Roger Penrose, he will instantly tell you, and he can even do that in 4 dimensions, let alone 3 dimensions. So, you know, mathematicians who
Fuck.
work on these things can not only work on them mathematically, they can understand them, they can grok them. Now, probably even Penrose couldn't do 20-dimensional one, but actually the answer is it's a perfect hexagon. And another kind of person who knows that off the top of their head is a crystallographer. Because they know that I think it's a face-centered cube, or is it a body-centered cube? But one of them, anyway, in the crystal structure, is the same as a hexagonal close-packed cube. You only got to look at it from 30 degrees different angle, and it's a completely different crystal.
Yeah.
And
what you said a moment ago about not being able to imagine the far side of a cube is so fascinating, because you're so right. Like, the moment you're thinking about that face, it's no longer on the back of the cube, and yet there's no trouble. I mean, this is weirdly consoling that there's no trouble in our brain not being able to really conceive of that. I still know what it means to say the other side of a cube, and maybe there is a sense in which we can grasp the majesty of the universe in at least that sense, even if we can't really picture it in our mind's eye in the same way that we can't picture the far side of a cube.
The pictures in our mind's eye are tools, just as the mathematical equations are tools, the diagrams we draw on paper are tools. They're all tools that we use, and we can actually use them to understand the world, not just predict. We can understand it in however much of its majesty we want.
Well, what a brilliant place to wrap things up after such a wide-ranging and technical conversation. That's a wonderfully optimistic place to leave things. I appreciate you taking the time. I need to take you off this fridge that I've laid on its side and put it upright again and onto the other side of the hotel room before someone notices that I completely upended this place. So I'd better hop to it. But David Deutsch, thank you so much for coming on Within Reason. It's been fun.
Oh, thank you for having me.
If you enjoyed that conversation, you can watch more episodes of the Within Reason podcast by clicking just here. But remember, the show is also on streaming platforms like Apple Podcasts and Spotify. Don't forget to subscribe. Thank you for watching, and I'll see you in the next one.
I hate this level. I'm too much of a kid for that level. What is that high at the beginning?
To talk to you, I was reading your book just recently on an aeroplane, actually, which is content. But now I give you David Deutsch. David Deutsch, welcome to Within Reason.
Hi.
I'm
His haircut is not that bad, maybe. What was it that I wanted to watch? I don't want to watch anything. I want to die at least at this point because of that fucking Polish alphabet. Get real. Fucking Polish alphabet. Let's watch her, I guess.
Susan Neiman, welcome to Within Reason.
Oh, she's kind of low.
So you wrote a book called Left Is Not Woke,
Down below.
and you've said somewhere that some of your friends practically begged you to not write a book with the word woke in the title. Why is that?
Because woke has become a slur by the right, and it's used to attack anybody who is engaged in working against racism or sexism or homophobia. I don't really know anybody who would define themselves as woke. It's really turned into a term of abuse, and people were afraid that I would be instrumentalized by the right that my book would be seen as contributing to that. And it's even the case that my French publisher decided not to do the book, although she had just very successfully published 2 of my older books, because she was afraid of giving aid and comfort to the right. Now, actually, a larger French press is going to publish it in the fall. I did 2 things to avoid being instrumentalized, because I am very much not a creature of the right. Okay. Number 1, I wrote on the very first page of the book that I consider myself a socialist, which makes it sort of hard for right-wing people to, instrumentalize you. And the other is that I've refused to do interviews with blatantly right-wing media. And, I've certainly had invitations, but I have not done that. And I don't actually think, it seems clear that people who actually read the book or listen to me talk, that it is not another right-wing rant about, anybody who objects to discrimination and domination. It's a very different argument.
Yeah, you see a lot of people making this complaint about wokeness and how it sort of ruins the left. And of course, it makes sense for people on the left if this concept of wokeness, whatever that may be, has ruined the left. It makes sense for people on the left to make that criticism. But it does feel as though most people who are claiming this are actually coming from the right. I feel like there's a big confusion that goes on. You get a lot of people saying things like, well, I'm a person of the left, but even I think all of this, cancel culture stuff's gone too far and everything, and I'm not even quite sure what it means to be on the left anymore with regards to this kind of debate. I don't know if you feel the same way.
No, I don't, because actually my book was an attempt to define what it means to be left, not an attempt to define woke. Believe me, many more people say these things when in private than they do in public. And I have had so many people come to me or write to me or say, I'm so glad you said this. This is exactly what I've been thinking. But I didn't want to say it out loud, either in some cases, frankly, because they were afraid. It depends on their position. But also because they felt they didn't want to betray people who they felt were, on their side in some sense. Look, the reason why it's so hard to define woke is that it's an incoherent concept. It depends on a clash between emotion and thinking. So woke relies on emotions that are traditionally left in every sense of the word. One wants to, when push comes to shove, be on the side of the underdog, of people who are marginalized, of people who are oppressed. One wants to correct the crimes of history, and if you can't make up for them, at the very least, you should remember them. Okay, so those are all emotions that I share and that I think are common to virtually every person on the left liberal spectrum of politics. The problem is, which many people don't realize, is that those feelings are undermined by what are actually very reactionary thoughts. And they're thoughts about what matters in one's own identity. They're thoughts about whether you can distinguish power from justice, and they're thoughts about progress. And what the book argues is that it's a fundamentally reactionary view that the only people you can have genuine connections to are members of your own tribe, be the tribe your ethnic background, or possibly your sex or your sexual orientation. Those are the only people you can really trust and who will really understand you, and therefore the only people to whom you have real obligations.
What? You can die
That's
like
a very
this?
right-wing thought. And for the left, it's fundamental to think, no, I can have deep connections and real obligations to all kinds of people. They're not limited to my own tribe. That's actually the point of being on the liberal left, is a kind of universalism, which
How
leads
did-
to a view of universal human rights. So
Prime
that's the
Minister
first
Sterling.
point
Ma.
of a difference between left and right. The second one is
yes.
people on the left believe it's possible to distinguish justice and power. And sometimes it's very hard to do that in a particular case. And most people who start wars claim that they're starting them for reasons of justice or to spread democracy to Iraq or whatever it is that they claim to be
Sure.
doing.
Yeah.
And in fact, those are rhetorical ways of hiding the fact that they're after some kind of regional power. But what people on the right tend to do is to say, it all comes down to power. Any claim to be working towards human rights, any claim to be, guided by certain ideals, is really just a disguised claim to power. Okay? One of the reasons why I talk in the book about evolutionary psychology is that has come along and seemed to give a kind of scientific foundation for the idea that, you may think that you're writing a love song, or, volunteering for some important community cause, but really what your genes are doing are trying to multiply themselves. And, that's something that's come to be accepted as scientific by virtually everybody on the political spectrum. But it's only the right that has long put that in front and center of an ideology, okay? And the third thing that leftists and liberals have in common is a belief that it's possible to make progress, whereas reactionaries tend to think that we went downhill at the Garden of Eden and possibly will be saved, if we believe in the right religious form. So they're constantly bringing up ideas of a golden age that, we've fallen from and probably can't get back. The interesting thing that the left has
that
done,
wasn't hard.
thanks to people like Michel Foucault, the most single-quoted author in all the humanities and social sciences for quite some time, certainly right now, is they take out the golden age. Okay, there never was a golden age. There were just raw expressions of power turning into more subtle expressions of power. And this is a line that you hear from very many people who think of themselves as being on the left. Now, of course, if you ask an activist, are you striving for progress? Are you trying to make progress? They would say, particularly for activists on the ground and not academics, they would say, of course I am.
Not bad.
But then
Last 22,
one might
nada,
say,
means
so
2.2.
give me an example of some progress that was made in the past. And that's where you see that they don't actually believe in it as
Gonna
something
let Christina
that's a
Waldau.
real fact. Because, you have people like
I
the
managed to do so long
Afro-pessimists
ago.
saying things like racism
little
is
damn
baked
sweats.
into the DNA of the United States. Well,
So
first of all, even using metaphors like that suggests you can't possibly
gonna
get
do it
rid of it.
again.
To say that the U.S. has a long racist tradition is
Where's music?
certainly true, but to ignore the fact
Where's
that people
music?
fought and died for progress, towards
Osaka.
a less racist society, is also to, deny their memory and deny their struggle, but it's to deny common sense in ways that we can actually reliably measure. So those are three ideas that I think really do make sense to say, okay, anybody that I would call on the liberal left has, believes in universalism, justice, and progress. Those are all ideas that come out of the much maligned Enlightenment. Now, I add a fourth principle that distinguishes the left from the liberals. For people who are on the left, social rights are
What?
genuine human rights, and they're every bit as important as political
What?
rights.
Why
So,
am I dying?
you know, healthcare and education and
Stop.
housing and work and access to culture are
Stop.
as important as the
Avoid.
right to travel or the right to speak for people who are on the real left. Whereas liberals tend to look at those things as nice if you have
Why am
it,
I
but they're
dying?
not human rights. Actually, both of those
What's wrong?
were written into the 1948 UN
I don't understand.
Declaration of Human Rights
Everything feels so foreign.
and given equal weight. So
It does not
not
feel
a lot of
like.
people like to remember that today, but it's
Why
true.
is.
So that would
Why am
be
I
my
dying?
distinction between
What is
left
happening?
and liberal. But I would be
Why?
happy these days, given that fascism is growing on every
I'm fucking
single
tired. Goodbye.
continent. I would be happy to make common cause with people who only agreed with the first three of those principles. That people who are liberals and don't share my view that you actually do need social rights in order to have a real exercise of political rights.
Sure. It's a comprehensive and interesting analysis of what it means to be on the left. The book is Left is Not Woke. I suppose people will hear that, and firstly, there is this culture of woke bashing that goes on the internet. It's very tired, it's very boring. I think that even putting out an episode like this that mentions so-called wokeism, people without watching it will go into the comments and say, oh, for goodness sake, you're talking about wokeism again. Because, I've spoken to people on my podcast who are sort of, anti-woke figures, people like Konstantin Kisin or Andrew Doyle. And a lot of the time people
Or
say,
Richard
it's
Dawkins.
getting a bit tired, it's getting a bit boring, and it's all a bit silly. But it's funny because you're obviously not doing that, and you say that you've been proactively avoiding that kind of thing, but at the same time you must be doing some kind of
Why am I
so-called
dying?
woke bashing that is saying that something's wrong with wokeness.
I just don't
and that,
understand.
it's not as tied up to the left that
I
you've just described
just-
as it is. So what is it that you're
I
saying
never
about
typed
wokeness,
this.
and how is it distinguished from the left? And if it's not on the left, I
How
think
is
people will
that?
immediately see the title of your book and say, well, if wokeness is not about being on the left, then what is it about? Is it being on the right? That surely can't be right either.
Well, that's exactly why I started at the beginning by saying it's an incoherent concept because it's based both on very left-wing emotions, which sweep us along. Oh, they're, on the side
Wait,
of people
wow.
who are victims of racism or sexism or homophobia. That sounds like left. And that's absolutely right. The emotions are really very left, but they're undermined by a whole host of philosophical assumptions that are actually very reactionary. And one example that I start with in the book comes from the New York Times. I can give other examples. The point of the book was
What?
not to do a bunch of woke bashing by listing a bunch of examples.
What?
Some people in Germany particularly attacked me for not giving enough examples. I said, you can
I
find
just
them in
don't
any
understand.
newspaper any day. Why? This is boring to
I
list
just don't
stuff.
understand.
And it's the kind of thing
I
that
just
people
don't
do,
understand.
after work over a drink, whatever
I just don't understand.
political orientation they have. It's quite
I
easy
don't
to
understand
make
my
fun of the
deaths.
examples. But here's an
I beat it
example
in one
that, as
fucking
far as I know, nobody
in
made fun of, and few people
134
even
attempts
noticed.
100
This
years
was
ago.
shortly after
That felt so natural.
Joe
I did
Biden
not even
and
use no
Kamala
clip. I
Harris
didn't
were
use
sworn
anything.
in
And now I just died to
presidency
everything.
and vice presidency. And the
I
New York
don't
Times
get it.
noted, well,
I don't
despite
get it.
Vice President Harris's Indian roots, Biden may not be as forgiving towards the Modi government as one would think, or something. And this is one of these sentences that you just run by, and you don't really think about and try to analyze. Okay. Now, I happen to wish the sentence had come true because, in fact, Biden gave Modi the most lavish White House state dinner that anybody has been given. He's using him, to try and shore up his anti-China policy. Okay. But the philosophical assumption that gets buried in a sentence like that is people's voting choices are determined by their ethnic background. Okay.
Right.
And of course, because Kamala Harris's mother is Indian, she's going to support the Hindutva fascism, as my Indian friends call it, of Narendra Modi. But in fact, the people who I know are the fiercest opponents of Modi are Indian because they actually know what's going on and they follow the news rather carefully. So, you know, there are thousands of assumptions like that we go through every day without really seriously thinking about. And one thing that I hope the book will do for some people is to sensitize us for the host of philosophical assumptions that get smuggled into your daily newspaper.
Sure. Yeah.
And to
Yeah.
think, and
Yeah.
you know,
I wonder exactly. I mean, we're sort of. You say that wokeness is an incoherent concept, but the term has to have a referent to be able to talk about it. It has to have some kind of referent, and so something about this idea of identifying people with their ethnicity essentially, or assuming ideological positions based on their ethnicity maybe has something to do with wokeness, but obviously that alone can't quite function as a definition. So what are we driving at here?
well, you know, if a concept is incoherent, it cannot be defined by, So I mean, I could give you a list of examples.
Woke means basically empathetic. That's it.
But
Right.
you don't want that. We've all been through that. I'm trying to say the concept is incoherent because it depends on
Right wing are so
total
fucking dumb.
confusion between
Hope they all
emotion
die.
and reasoning.
Oh wait, you cannot say that.
One
That was a
huge
joke.
part of it is indeed believing that all the identities we possess, each of us possess, can be reduced to ethnic background and sex. Okay. Now, I don't use the word identity politics, and I don't use it for a reason, because it begs the question of whether or not those things do make up our identity. They're certainly parts of our identity. But I challenge anybody to take out a piece of paper and write down 10 things that are really important to you, that you would not be who you are if you lost whatever it is. An idea of whom you love, an idea of your profession, if your profession is important to your identity. Not everybody's is. Your political leanings.
This is so
Some
pathetic.
people are such passionate musicians that even if they aren't professional musicians, certain pieces of music, certain kinds of music are absolutely essential to their identity, and so on and so on. I've sometimes said people identify with their football teams, which I find rather bizarre. And then I'm sometimes told this is, I'm trivializing the idea of identity. And then someone else will say, not if you're from Glasgow, or not if you're from wherever it is, So I don't get it, but I do know that some people are. What's so interesting about all
Where do I find that?
is that those are by and large things that we choose.
Where is that fucking level?
World, and in the world of forming ourselves, forming our own identity.
What fucking...
The two things that get called identity politics are the two things over which we have absolutely no control. And there are also two things in which we're therefore actually quite vulnerable. So it's an identity based on possible victimhood, that is passivity, rather than what we actually do in the world and what we decide. And I think that's a very sad way to look at basic questions of identity. But that is very much the second.
Certainly.
Yeah. The second is, again, as I said before, the belief that there aren't any real conceptions of justice. It's all kind of hype to disguise power relations. That's a very strong tenet that you get running through an awful lot of woke discourse, and it comes, one can trace where it comes from in terms of philosophical theory. And the third is a
Rockets.
distrust or even a rejection of the idea of progress, no matter how it's played. One thing that all of the people who I would
Oh,
call
720,
woke have
and my
in
game
common,
does not
even if they
lag,
wouldn't
actually.
sit down at the table together, is the fact that they believe that the Enlightenment is a source of Eurocentric, patriarchal, white ideas that were forced on other parts of the world and that are not, in fact, in any sense, universal. Okay, and that is one line.
Is the thunder? Are those rockets or what are those? I hear sounds. Are those rockets? Fucking
basically
Russians.
post-colonial theory has pushed and actually made lots of people extremely nervous and uneasy about not just about saying anything good about the Enlightenment, but saying anything good about the West or the North, whatever direction we feeling like calling, you know,
Yeah,
Europe and
yeah, sure. I want to go back to the first point that you made about reducing identity to two things, race and sex, and you pointed out that if you're asked to write down a number of your most important identities, you might write
Nah, I
musician,
wanna die.
mother,
I
you
wanna
might
kill
identify with
myself.
your sports team. I think there are a few things to say about this, especially the point that the two that we've landed on here
Oh
are
yeah,
the
I
ones
wanna
that you don't
die.
choose.
Oh yeah,
And that's that
absolutely.
if you asked me to write down which identities were important to me, I'd probably, yeah, I mean, I don't think I'm going to write down my sex and my race. I think two critiques that people would make of that is firstly, that's because if you were to ask somebody which of their important identities
I will never beat
do
this
they
level.
cause them to suffer the most political inconvenience, then suddenly I don't think they would be writing things like their football team or the fact that they're a musician. And so in the conversation about politics and the conversation about justice, those identities just sort of don't become relevant. And so in the political arena, it kind of makes sense that those aren't the ones that are coming up, right?
So
And the fact
few
that you don't
likes.
choose them maybe is the point. You said it's a sad way to look at things or something
For a
like that,
good
but maybe it's
video.
just, as people see it, a sad reality of the world that there are these
Alright,
factors
this
which are
is
outside
useless.
of
I will
people's
never
control,
get anywhere.
which are significant sources of their political unluckiness in a way. You see what I'm saying?
Yeah, I see exactly what you're saying. You're giving a good definition of the concept of intersectionality, which when I first heard of, I thought, oh, goody, somebody
Is that
is actually acknowledging
is that a
that
thunderstorm or are those rockets? Let me
sex,
fucking check.
But it's not.
Ah yeah,
It's
those are rockets.
intersectionality is about the fact that we can have multiple identities that determine how we suffer or
So this ne.
how we're discriminated
Yeah,
against.
those are rockets.
And I just think, first of all, as a way of looking at anything, but certainly even the political world, I don't think that that's the way we want to define ourselves. Look, something that will come, has become increasingly relevant in the last few months. Defining, I'm Jewish, but I belong to the universalist tradition of Jewish thought, and it goes all the way back to the Bible, and most of the
Nah,
famous
this is
Jewish
useless. I
thinkers
will
you've
never do this level.
ever heard of are people
Although I
who
beat
were
it
in
already
that
like 10
tradition,
times.
okay,
But
rather
I will
than the
never rebeat it.
nationalist
Because
tradition.
I'm weak.
At the moment in Germany, as you may have
Fuck me.
read, in fact, there was a Guardian piece last week in which I was
I don't know,
quoted.
guys. There are fucking rockets outside.
Germany has
And what? Those drones, yeah, drones. Maybe even you can hear them. What do you think, guys? Giant? You mean? Not really. Well, so many rockets. I should go outside and look. I can hear him so clearly. Alright guys, I want to go and watch what's happening outside. Goodbye.